We'll conclude this section with some examples. In the first example, we're asked to write down the form of a particular solution to the equation y double prime plus 2y prime plus 2y equals 5 times e to the power negative t times sine of t plus 5t cubed times e to the power negative t times cosine of t. So when we look at the particular solution, on the one hand, we have to compare this with the general form of the right-hand side. So we're going to compare this with, on the right-hand side, p m of t e to the power alpha t cosine beta t plus q sub n of t times e to the power alpha t sine beta t. And then on the other hand, we also need to figure out what are the solutions to the auxiliary equation. So here on the right, the auxiliary equation for this differential equation is r squared plus 2r plus 2 equals 0. Now, I'll leave it up to you to double check that the auxiliary equation, the solution to this is r equals negative 1 plus or minus I. So pause the video and make sure that you can find these roots. So we need to be careful when we look at our alpha and beta. So alpha equals negative 1 and beta equals 1. And that determines whether or not our particular solution has an extra factor of t. So when we compare this, we see the following. We see that this factor right here, that's our pm of t, and that is 5t cubed, right? The pm of t is the one in front of the cosine. And then right here, we see that alpha equals negative 1 and beta here equals 1. So what we see here is that that is a alpha plus or minus I is a root of the auxiliary equation. So that means we're going to have that extra factor of t in our solution. So this part right here, the 5, that is our polynomial qn of t. And then again, what we have here is that alpha equals negative 1, and then we have beta equals 1. So we can combine these two terms into one particular solution. So our particular solution, we now need to look at the degree of these two polynomials. So the first polynomial here has degree equals 3, and this polynomial has no t, so the degree equals 0. So that means that the maximum of these two, so the maximum of those two is 3, and that means that our particular solution will have a general polynomial of degree 3. So let's write that down. So we have yp of t is a power of t to the power, or t to the power s, and then a general polynomial of degree 3, which looks as follows: a3 t to the power 3 plus a2 t squared plus a1 t plus a naught. And then we're going to have e to the power negative t cosine t. And then we have to do the same thing for the term with the sign. So we have plus t to the power s, and then b3 t cubed plus b2 t squared plus b1 t plus b naught, and then e to the power negative t sine of t. So let's go ahead and actually put in that power of t. So because alpha equals -1, beta equals 1 is a root of the auxiliary equation, we actually know that that power of t is going to be 1. So this is t to the power 1, t to the power 1, and that is our final answer for the particular solution. Okay, now let's do another example where we will write down the form of a particular solution to the equation y triple prime plus 2y prime plus y prime equals 5 times e to the power negative t sine t plus 3 plus 7t e to the power negative t. Now, this is a problem that's a little bit more complicated than you'll see on the midterm, but it shows the versatility of this method. So again, the two things that we want to do is we want to look at the auxiliary equation on the one hand, and on the other hand, we want to compare this with the general form on the right hand side. So let's take a look at the initial condition, or the auxiliary equation, excuse me. So the auxiliary equation for the right hand side is r cubed plus 2r squared plus r equals 0. There's no y here, so there's no constant term, and that lets us factor out the r, and then we have r squared plus 2r plus 1 equals 0. And that second term, that factors as r plus 1 squared equals 0. So then we have r equals 0, or r plus 1 squared equals 0. And so that means r equals -1, and that has a multiplicity that's equal to 2. And that's that 2 in the power there. Okay, so those are the roots of the auxiliary equation, and now the right-hand side does not neatly fit any of the two general forms. In fact, we'll have to break this down into 3 parts. So I'm going to take a look at this part. I'm going to find a particular solution, yp1. Then the second part right here, the plus 3, I'm going to find a yp2. And then finally, for the third part, I'm going to find a yp3. So let's do that down here. So for yp1, I have that my f of t equals 5 e to the power negative t sine of t. And so that means that I want to compare this with something that looks as follows. The right hand side is Pm of t times e to the power alpha t cosine beta t plus q sub n of t e to the power alpha t sine of beta t. Now, since my left-hand side only has a sine, that means that the cosine is gone, so I see that Pm of t is just 0 because we don't have a cosine. And then the Qn of t, that's the polynomial in front here, so that is just 5. And then if we compare alpha and beta, we see that alpha equals -1. That's the coefficient in front of the t, and the coefficient in front of the t, that's beta equals 1. So this compares with a root of the auxiliary equation that's -1 plus or minus I, right? Alpha plus or minus beta I. Now, that's not a root of the auxiliary equation, so our particular solution will then look something like this. So yp1 of t. Let's take a look at the maximum degree. So the 0 we can completely ignore, and the 5, the polynomial 5, has a degree. Since there's no t, the degree is 0. And so the general polynomial of degree 0 will just be a constant. So our function, our particular function, will look something like a naught times e to the power -t cosine t plus b naught e to the power -t sine of t. And then we have to multiply that by a power of t, and that's t to the power 0. And so that is just going to be 1 when we simplify it. But notice for the particular solution, even though only sine shows up for the particular solution, we always have that cosine and sine show up as a pair. Okay, now let's move on to the next part. So our second particular solution, the right-hand side, let's call it f2 of t. Let me go back and call this f1 of t. The function that we have to look at is the constant function 3. So what do we have to compare that with? Our general form of the equation on the right-hand side. The general form looks as follows. that's Pm of t times e to the power rt. So when we compare that, we don't see an e to the power t here. So we can actually think of this as e to the power 0t. Right, that's 1 there. And so when you compare that here, you see that Pm of t is just 3, and then r equals 0. Degree of this polynomial is 0. There's no t to the power, so the degree is 0, and that means that our general solution for the particular solution, or the, will look like this. Yp2 of t is going to be a general polynomial degree 0, so that's going to look like a naught, and then e to the power 0t, and then we have to multiply that by a factor of t. So we need to look at the multiplicity of the root r equals 0 and see if that's part of the auxiliary equation. And we see that that is part of the auxiliary equation. So that will be a t to the power 1. And so if you then simplify that, that's going to be a naught t, and then e to the power 0t is just going to be a naught t. And let's go ahead and go back and simplify this as much as possible. So this is a naught e to the power negative t cosine t plus b naught e to the power negative t sine of t. And then finally, our yp3 is associated with f3 of t. So again, this is not yp3. This is, I should probably write that this is, let's call that f3 of t is that which is associated with yp3. Let's do the same thing here. This is f2 of t equals 3, which is associated with yp2. And then this part is f1 of t, which is equal to this function, which is associated with yp of 1. Okay, now for f3 of t, that part is equal to 7t e to the power negative t. Okay, and let's compare that with the general form on the right-hand side. So we have to compare this again with pmt e to the power rt. So what we see is that the polynomial Pm of t is 7t, and it means that the degree is 1, and then the second part is the e to the power rt. Well, that's the r equals -1 here. R equals -1. Now, r equals -1 is a root of the auxiliary equation, and in fact, it has multiplicity 2. So that's something that we have to be careful about. So we had degree equals 1. And so our particular solution will look something like this. Yp3 of t So power of t times a general equation of a general polynomial of degree 1, which looks as follows: a1t plus a naught, and then e to the power negative t. And now we have to put in, we put in a factor of t, and because this has multiplicity 2 in the auxiliary equation, we have to multiply that by t squared. And then the final particular solution is the sum of these three parts. And let's simplify this part right here before we do that. So this right here, if we distribute the t squared, gives us a1t cubed plus a naught t squared, all times e to the power negative t. So let's combine all of this, and then I'll put my final answer here. Yp of t by the superposition principle will be yp1 of t plus yp2 of t plus yp3 of t. Now we have to be a little bit careful because I use the general convention of giving these coefficients a name, but a naught here will not be equal to a naught here, or equal to a naught here. So let's just give those variables a slightly different name. So I'll just put these values, let's turn them into red. So I'm just going to call this A, I'm going to call this B, I'm going to call this C, I'm going to call this D, I'm going to call this E. So then what I get for my particular solution is yp1 is A times e to the power negative t cosine t plus b times e to the power negative t sine t plus yp2, I just called that C2, or I called that C, times T, right? That A naught T, I called that C, C times T, and then finally plus yp3 of t. That's going to be d times t cubed plus e times t squared times e to the power negative t. And that is the form of our particular solution.